Hi everybody, Mrs. Jensen here. I want to take a couple minutes and talk about the Chapter 1 performance task that you're going to be working on Monday. You'll see it's here on Monday of week 6. So I'm going to click into it. It'll be done in Kami, so you can type into it. Here it comes. Slowly loading. And really what it does is it relates back to the video that you hopefully looked at the beginning of Chapter 1 about the freezing points and boiling points and the positive, negative numbers. Well, we're going to take a look at that here in terms of melting and what happens when things change from solid to liquid or from liquid to solid. And that happens at different temperatures for different substances. And we're going to compare them to ice, and we're going to use Celsius. So that's why in the chart it says ice 0 degrees Celsius. And these are the temperatures when a solid becomes a liquid, or it's a melting point. If you're going the other direction, then I guess it's its freezing point. You're going to use this table here about ice, beeswax melting at 62 degrees Celsius, mercury at negative 38.83, plastic, tin, ethanol, acetone, and chocolate. Yummy. And you're going to use that to answer your questions here. Now, where it says graph each melting point on a number line, which substance has the highest melting point, do the best that you can to draw these out and label them. You can use the drawing features over here on the side on Kami to help you, then answer the questions here. Order each melting point from closest to farthest away from the melting point of ice. So think here, that's distance. What do we have to look at in terms of distance on a number line? What do we call that? Then if you go to the next page, it talks about dry ice. That's carbon dioxide in a solid state, and where its freezing point is at negative 78.5 degrees Celsius. And they use it to freeze liquid mercury when it's at room temperature. So here, the negative 78.5 degrees, I'm just going to give you a heads up, that's just information for you. You're actually going to use this 22 degrees Celsius for room temperature. And if we go back here, the freezing point of mercury, or melting point of mercury, the negative 38.83, you're going to use those two numbers and find the difference to tell how many degrees Celsius the temperature needs to drop. Let's see here. Then you may do a little bit of research about the melting point of mercury compared to its freezing point and its boiling point. And what do you notice? And then noting that the coldest temperature ever recorded on Earth was negative 93.2 degrees Celsius, would a mercury thermometer work in that region, and why or why not? So hopefully this gives you a little insight on what you need to be doing for this activity. If you got any questions, let me know. Bye.